Lesson 28 is entitled Calibration of Laboratory Equipment. In today's lesson, we will cover the following topics. What is calibration? I will discuss a little bit around the background of calibration and calibration programs, how you calibrate equipment, the process involved in calibration, and what happens when you fail a calibration, and finally the conclusions. So to start with, we'll discuss the definition of calibration. And the definition is as follows. Verify to calibrate an instrument is to verify instrument specifications by measuring actual performance using external lab standards that in turn have a better performance and are traceable to the International System of Units via National Metrology Units, or NIST. And this is the link for the NSAI website. It's based in Glasnevin in Dublin, and this is where most of the equipment go for calibration. So if we're sending out standards for calibrations or calipers or pressure gauges or anything like that, they go up to the NSAI Centre for calibration there and sent back then down to the laboratory. How do I ensure valid results? So monitoring and measuring equipment must be calibrated or verified at specified intervals or prior to use. Equipment must be adjusted or readjusted as necessary. Equipment must be identified to enable the calibration status to be determined. Equipment must be safeguarded from adjustments which would invalidate measurement results. And equipment must be protected from damage or deterioration during handling, maintenance, or storage. So why do we need to calibrate instruments? Well, the primary reason is to conform with regulatory standards, namely the ISO 9001. And calibration of equipment ensures that on an ongoing basis that the equipment is performing properly and accurately at all times. Often calibrations, the tests involved in calibrating a piece of equipment are normally subsets of the qualification tests performed during the IQ/OQ phase. The responsibility lies with the user, so users are ultimately responsible for instrument operations and data quality. The users group encompasses analysts or supervisors, instrument specialists, and organization management. Users should also be responsible for qualifying, calibrating their instruments because their training and expertise in the use of instruments make them the best qualified groups to design the instrument tests and specifications necessary to ensure compliance with ISO calibration requirements. How do I control monitoring and measuring equipment? Records of calibration and verification of results must be maintained. The validity of previous measurements when a device is found not to conform to the requirements must be looked at. Computer software used for monitoring and measuring must be validated prior to initial use, and the same computer software used for monitoring and measuring equipment needs to be revalidated as and when necessary. Systems must be in place to ensure that all instruments are calibrated and also to prevent use of an instrument that is not calibrated or unusable due to damage or malfunction or has exceeded its established calibration interval. Systems must be in place that identifies instruments that do not require calibration to be performed beyond the original or the factory calibration to distinguish from those instruments that do require scheduled calibrations. How often should we perform calibration on our instruments? Often the instruments come supplied by the manufacturer calibrated, and normally the default is set at a year. Scheduling. When you're scheduling calibration of equipment in the laboratory, it's very important to avoid complete absence of equipment. So for example, if all balances are due to be calibrated on the same day, you may have a situation where there are no balances available for use on the same day. The calibration frequency should occur at regular planned intervals or prior to use. And sometimes unplanned calibration can be called for when the instrument is physically moved to a different location within the laboratory. If a balance is picked up from a fume hood and moved to a worktop or bench top, it needs to be recalibrated. Unplanned calibrations are called for when questionable or ambiguous results are obtained, perhaps as part of a deviation or a lab investigation. It may warrant a recalibration of your piece of equipment that was used. So calibration specifications. Instrument calibration tolerance limits should be established so problems are identified and corrected in a timely manner. And when assigning tolerances, considerations need to be given to the capability of the instrument being calibrated, or what the manufacturer claims the instrument can achieve. You need to consider parameters at which the instrument operates. For example, if testing accuracy of if a testing accuracy of 0.5 is required, then the instrument calibration tolerance should be less than 0.5. You need to consider the work environment, because sometimes environmental conditions can affect the performance of the instrumentation. So if balance again, if it's in a fume hood or in a laminar flow hood, you need to take those environmental conditions into consideration when calibrating that balance. So calibration standards are tools used to calibrate your own laboratory equipment in your own laboratory, and these are usually limited to mechanical equipment. Standards are sent out externally to be calibrated to the NSAI Centre in Dublin, for example, and these include things like weights used for balance calibration, or thermometers used in the laboratory, calipers, particle size instruments, or sieves, things like that. Instruments can be classified into 3 different groups, and depending on what particular group the instrument falls within, that will specify the different types and the tolerances of calibration requirements set. So instruments are normally grouped into A, B, or C, and any instrument falling within group A normally requires no measurements capabilities, or doesn't require calibration. For example, things like mixers or hot plates or centrifuges. Group B then is instruments providing measurements or controlling physical parameters such as temperature, pressure, for example, balances, thermometers, pH meters. And finally, Group C are the more sophisticated instruments like HPLCs or GCs. So all equipment, whether they're Group A, B, or C, they must contain an equipment label. And the equipment label is really the identification of that piece of kit. And at a minimum, it needs to contain the permanent serial number of the equipment, as well as the calibration label. And that label needs to indicate the date that it was last calibrated, its next calibration due date, and the person who performed the calibration needs to sign and date that label. So all quality systems need to have a calibration system in place, and it needs to include specific directions within that operation system that specifies the schedules of what equipment is due for calibration and when. It needs to specify the limits of accuracy and precision of the equipment, as well as any remedial actions that need to be taken if an instrument fails calibration. The system needs to prevent usage of instruments that have failed calibration. The system needs to track instruments' calibration status, and each instrument must be given a unique identifier or a unique number, and within that identification label, it needs to contain the serial number, the model number, the location of the piece of equipment, the calibration status of the equipment, the date it was calibrated, the next calibration due date, as well as the initials of the person carrying out the calibration. And appropriate systems need to be in place to document calibration status. So normally we use logbooks to calibrate, to document if an instrument has been calibrated and its next calibration due date. The calibration process itself then, so a written standard operating procedure needs to be in place where traceable calibration standards or calibration equipment is used at all times. Calibration can only be carried out by a qualified individual having the appropriate education, training, background, and experience. Normally, a calibration technician is assigned to calibrate and maintain instrumentation within the laboratory. Calibration requires a second person sign-off or a second person verification of all the calibration checks to ensure that they have been carried out and that they pass the acceptance criteria or their tolerances set. You need a qualified individual responsible for monitoring the calibration program or the calibration system. You need to ensure that the calibration program and the procedures are reviewed and approved by the Quality Assurance Department. Each calibration maintenance procedure should include the following at a minimum: identification of the department responsible to perform the calibration or maintenance, step-by-step calibration instructions, reference to appropriate calibration procedures or instrument manuals, methods for preventative maintenance, or reference to appropriate instrumentation manuals, calibration equipment used in the calibration, for example, digital thermometers, voltmeters, balance weights, etc. And it needs to include calibration parameters and the acceptable tolerances. The records then, so each piece of equipment needs to have a certificate of calibration. The equipment log then should be in place for every piece of equipment, again detailing the equipment manufacturer and model serial number, calibration interval along with the specifications and the date of last calibration. And all records of equipment calibration need to be reviewed and approved by an individual who did not perform the calibration. So a second person verification is required. Signature and date of that person indicates approval of the document. We need to think about the retention of the records. Who is responsible? Are they easily accessible? And are they available by all analysts or by auditors when required? So what happens when a piece of equipment fails calibration? What does this mean? So if it fails calibration, it means that the equipment might require adjustment to be returned to acceptable operation, or any equipment that cannot be brought back into acceptable operation, even with adjustment, is considered to have failed calibration. The process involved in highlighting a failed calibrated piece of equipment is to immediately tag the instrument as being defective or remove it from use. You document the specifics of the out of calibration condition, normally through a deviation record. You forward the deviation record to the lab supervisor to determine the corrective action that needs to be taken. And very importantly, you need to assess the validity of previous data that was generated on that piece of equipment since the last passing calibration that was identified. So it widens the scope of your investigation if a piece of kit fails calibration. The out of calibration procedure. Normally a piece of equipment is said to fail calibration if the calibration is not completed within a specified time frame, if the results from the calibration do not meet the set criteria. It highlights the need to identify the causes for the failed calibration, which could include things like corrective action could include things like retraining the analyst on the calibration procedure, looking at the cleanliness of the glass or the validity of the standards, the external standards used as part of that calibration. Look at the maintenance records for the piece of kit, review the breakdown history or the malfunction history of the equipment in question to see can that provide any additional information. And also it'll prompt you to review previous calibration records for the kit. So data generated from the successful calibration till the next calibration is evaluated for the impact. So any batches that were tested since the last passing calibration need to be looked at. And if the impact analysis reveals suspect results on these batches, then with QA approval, random batches are selected and analysed, and results are compared to the original passing results. If the results are different, then appropriate evaluation and justification needs to be provided and approved by quality, QC and QA. Based on the outcome of the investigation, CAPAs are implemented and the recalibration of the equipment is performed. So some typical calibration parameters that are looked at for a HPLC instrument would include things like injection volume, accuracy, precision linearity, mobile phase adjustments, flow rate precision, column oven temperature, thermostat accuracy, detector wavelength accuracy, signal to noise ratio, etc. And all of these parameters would have acceptance criteria listed in the calibration procedure. So in conclusion, qualification or calibrations of equipment are not an option, but they're needed in order to comply with regulatory requirements. A strong calibration program ensures highly efficient laboratory operations, reliable results. It ensures quality products and patient safety. Thank you for listening.